Topic 10, Current of Electricity. Part 1, Current and Charge. Here we're doing a quick recap on electric charge. We have seen the flow of charges in electric fields in the previous topic. When there is a continuous flow of electric charge, then we get an electric current. In an electric circuit, when we close the switch, we are really turning on the electric field inside the wire. So we are not creating anything. The free-flowing electrons in the wire then start to drift or to flow along the electric field lines. Flow of electrons. Just look at this diagram here, which shows a section of a piece of wire. Inside the wire, once the switch is closed, there are these parallel lines representing field lines, like this. And then these are the electrons drifting to the right, like that. And the direction of these parallel field lines is left out deliberately for you to decide which direction these field lines are pointing, based on what you learned in topic 9, the previous topic. Are these field lines pointing to the left or to the right? You decide. Now you have to know the difference between electron current and conventional current. First of all, conventional current comes out of the positive terminal of the battery and into the negative terminal of the battery. Electron current is exactly opposite. It comes out of the negative terminal of the battery and into the positive terminal of the battery. The true current is the electron current. Conventional current is only by convention. It is conceptual, whereas electron current is real. For exam purposes, you are to stick to conventional current. So unless otherwise stated in the question, you are to assume that the current is conventional current, always. This is just reiterating what I talked about on the previous slide. Electric charge and current. First of all, you have to learn the definition of electric charge from the dictionary. Now, current is a flow of electric charge, which is usually electrons per unit time or per seconds. In the form of a formula, it's like this. Current is equal to charge over time. In terms of symbols, it's I equal to Q over T, or also small q over T. And the formula can be rearranged in this form. This is a simple example which requires a use of this formula you've just learned. I just want to point out that the common mistake people make is forgetting to convert minutes into seconds. Measuring current. See whether you can answer these 3 questions in regard to these 2 meters.